Hey everyone, and welcome. Today, we're diving into something really cool. A huge shift in technology. We're gonna move beyond tools that just, follow our orders, to ones that can actually think ahead. This is all about the rise of what's called adaptive intelligence. So, let me ask you something. That AI assistant you use every day, is it actually helpful? Or is it just obedient? I mean, think about it. Most of our tech just sits there, right? It's totally reactive. It's just waiting for us to tell it what to do. But that's all about to change. The next big thing, the next frontier, is all about proactive, adaptive systems. We're talking about tech that can actually anticipate what we need and even reshape itself to fit the world around it. Now, to really get what this means, we're going to look at two amazing examples. One's purely digital, and the other is very, very physical. All right, first up, the proactive digital agent. Let's see how this is popping up in our digital lives. We're going to dig into a whole new kind of AI assistant. It's an open source project called Clawdbot, and believe me, it completely breaks the mold of just waiting around for a prompt. Okay, so check out this comparison because the difference is just night and day. On one side, you've got your typical assistants, right? They're reactive, all your data is sitting on some corporate server somewhere, and the code, total black box. You have no idea what's going on. But then you have Claudebot. It's proactive. Get this, it messages you first. All your data stays right there on your own machine. And the best part, it's completely open source. And because it's proactive, it can do some seriously cool stuff. It plugs right into the messaging apps you're already using. I'm talking WhatsApp, Telegram, you name it. It can shoot you a morning briefing, poke you about calendar events, and here's the kicker, it stores all your conversations locally, just as simple text files. That means it actually learns your context over time. For real. Okay, but before you rush off to download it, there is a catch. All this power, all this control, well, it comes with a price. Complexity. I mean, just look at what this Reddit user said. I just finished setting up Claudebot and I'm pretty technical. It was tough. So yeah, this is not for the faint of heart. You got to be comfortable with the command line. You have to be willing to tinker. Right now, it's a tool for builders, not really a polished product for everyone. Well, not yet. Anyway. All right, get ready for a hard pivot, because this whole idea of adaptive intelligence, it's not just happening in software, not even close. Let's see how this is literally taking shape in the physical world. We're talking soft robotics. Okay, this is where it gets just wild. What you're looking at here are two forms of the exact same robot. Seriously, on the left, it's a cylinder, right? Built to roll super efficiently. But on the right, it's completely flattened out, ready to crawl. The whole problem for the people who built this was, well, how do you make a single machine that can handle two totally different environments? See, for this little guy, just changing how it moved wasn't going to cut it. A rolling shape, awesome for flat ground, but try to climb a hill with it? No way. And a crawling shape is the exact opposite. So to win in both places, it didn't just need to learn a new trick, it literally needed a new body. And that's where this idea of gait comes into play. You know, like how a horse can walk or trot or gallop. This robot has two totally distinct gaits. It can roll like a wheel, or it can do this slow, kind of deliberate, inchworm-style crawl just by bending its body. So we're talking two completely different ways of moving, made possible by two completely different shapes. And this isn't just some clever engineering hack. It's straight out of nature's playbook. As the researchers themselves pointed out, organisms in the real world have been doing this kind of thing for millions of years. I mean, think about a spider that curls up into a ball to roll away from a predator. This robot, it's basically just doing the same thing. It's all about adaptation. So, okay, we've got a proactive digital agent on one hand and a shape-shifting robot on the other. But how do these things actually go from being a cool idea to a real thing? Well, it turns out the process of making them is a kind of adaptation all on its own. And for the robot, it's this process called sim to real. It's brilliant, actually. Before they built a single physical part, the researchers tested thousands of different shapes and behaviors inside a computer simulation. They basically let an algorithm figure out what works best in the digital world. And only then, only after all that testing, did they build a winning designs in the real world. And guess what? The numbers prove it worked. Big time. When the robot was allowed to change its shape, it was just plain faster and more efficient across every single type of terrain they tested it on. This is the proof. Adapting its body, not just its behavior, was the absolute key to success. But you know, this whole idea of simulation and refinement, it isn't just for robots. Think about it. The open source community building Clawdbot is doing pretty much the same thing. They're constantly testing, tweaking, improving the code. It's like a human-powered simulation, iterating on an idea until it becomes a powerful, real-world tool. Okay, so let's bring these two threads together. What's the big takeaway here? What does a proactive AI assistant and a shape-shifting robot tell us about where all of this tech is actually going? So really, what do they have in common? I mean, a proactive digital assistant and a robot that changes its shape, they seem like they're from different planets, right? One is just pure code, the other is all physical. The answer is that they both point to a whole new way of thinking about technology. For decades, we've had to be the ones to adapt. We had to learn the rigid, weird rules of our tools. We changed for the machine. But now we're finally starting to build machines that adapt to us. They're adapting to our world. And that really leaves us with one last big question. When you think about it, from digital assistants that know what you need before you even ask, to robots that can literally reshape themselves to beat any obstacle, as our tools become less rigid and maybe a little more like living things, what kind of incredible